HIV stands for Human Immunodeficiency Virus and is a virus that targets the cells in our immune system. Untreated, HIV damages our immune system over time and eventually weakens our immune system to the point of failure. This causes a disorder known as acquired immunodeficiency syndrome, or AIDS. With AIDS, you're in a state where your immune system cannot function effectively, and thus, your body is unable to fight off even the most basic infections that a healthy immune system would easily be able to handle. Let's first take a closer look at the HIV virus itself. HIV consists of viral DNA encompassed by what is known as an envelope. HIV targets our immune cells. Specifically, HIV targets our white blood cells, including T helper cells, also known as CD4 cells, dendritic cells, and macrophages. More specifically, HIV targets a molecule on the surface of these cells known as CD4. CD4 helps our immune cells attach to and communicate with other immune cells, and therefore is very important for coordinating attacks against foreign invaders in our body. Thus, we rely on having an adequate number of immune cells with CD4 in our body to effectively fight diseases and stay healthy. CD4 is also very important for HIV, as it is the entry point for HIV to hijack our cells and infect our body. Among our immune cells, the main victim of HIV are our helper T cells. Let's now take a closer look at how HIV infects our helper T cells. HIV has a protein on the surface of its envelope that can target and attach to the CD4 molecule on our helper T cells. After HIV binds to the CD4 molecule, HIV then slightly modifies its protein so that it can bind to another receptor on the cell surface, known as the co-receptor. After using both keys to unlock the cell by binding to the CD4 molecule and the co-receptor, HIV then enters the cell by delivering the viral DNA into the cell. HIV is an RNA retrovirus. The RNA means that instead of being double-stranded like our normal DNA, HIV DNA only consists of one strand. The retrovirus refers to the fact that HIV requires an enzyme to complete the other half of the viral RNA to form a DNA molecule known as proviral DNA. The reason that it's called proviral DNA is because it can be directly integrated into the host cell's DNA. And that's exactly what it does. It enters the nucleus of the helper T cell and pops itself right in there into the DNA of the helper T cell. Think of the DNA as a blueprint for any cell to create more copies of itself and to create proteins. HIV has contaminated our blueprint by including instructions on how to make more HIV. The hijack of our helper T cells is extremely consequential to the progression of HIV in our body. First, because HIV is now included in our blueprint, our infected cell has essentially become an HIV factory, creating lots and lots and lots of copies of HIV and releasing it into our bloodstream. With more HIV in our bloodstream, this then leads to more of our helper T cells getting infected. This problem gets really serious when the HIV infection of your helper T cells then triggers the self-destruction of these cells. The self-destruction of the helper T cell can also destroy nearby immune cells. This is a bad combination. The rapid decrease in our immune cells, coupled by the rapid increase of HIV in our body, which then leads to more and more HIV infecting our helper T cells. Let's now visualize the progression of our HIV in our body by looking at the standard progression of HIV and T cell count in our body once we've been infected by HIV. On the x-axis, we have time, and on the left y-axis, colored purple, we have the amount of HIV in our blood also referred to as the viral load. And on the y-axis on the right, colored blue, we have the number of CD4 helper T cells in our body. As expected, the first few weeks of infection result in a large spike in HIV due to the hijacking of our CD4 cells and rapid copying of HIV. This is coupled by the rapid decline of CD4 cells, as the infected CD4 cells are destroyed by HIV. However, as HIV continues to increase, our body launches a massive counterattack against HIV by mechanisms such as producing HIV antibodies. Thus, our immune system starts to control the HIV levels in our blood to some degree. This in turn gives our body an opportunity to recuperate CD4 cells, as there is less virus in our body to infect and destroy these cells. This entire sequence is known as the acute phase of the infection. Symptoms include nasty flu-like symptoms, such as fever, headache, sore throat, muscle and joint pain. Unfortunately, our immune system cannot completely get rid of HIV from our body, and thus, then, we enter the chronic phase of the infection. In the chronic phase, the virus slowly chips away at our immune system, with HIV continuing to replicate and increase in our body. At the same time, our CD4 count begins to steadily decline as these cells get infected by HIV and get destroyed, representing a gradual deterioration of our immune system due to HIV. The decline in our CD4 count is a key indicator for the progression of our HIV infection, as it represents the general strength of your immune system. A healthy immune system typically has a CD4 count of between 500 to 1600 CD4 cells per cubic millimeter of blood. As HIV progresses and your CD4 count falls below 200 cells per cubic millimeter, your immune system becomes severely compromised. And it is at this stage that your condition has regressed from HIV to AIDS. Once you reach this stage of AIDS, you essentially do not have a working immune system. This is very dangerous, as at this point, certain infections, bacteria, and viruses that would have never seen the light of day against even a minimally effective immune system can now effectively attack, invade, and infect your body. This is the major danger of AIDS, not being able to effectively fight diseases that a healthy immune system could handily deal with. These infections that can now affect your body are referred to as AIDS-defining illnesses, as it would be extremely, extremely unusual for a healthy individual with a working immune system to have these illnesses. Examples of AIDS-defining illnesses include bacterial pneumonias and fungal pneumonias. Bottom line, when HIV progresses to AIDS, that's bad news. With a severely damaged immune system, you're more susceptible to opportunistic infections, diseases that wouldn't usually cause illness if you had a healthy immune system.